Hi, we're continuing with chapter 16. Where we had left off last week was we started going over the functions of additives. There are 4 potential functions of any additive. The first that we went over last week is preserving product quality. So we talked about preservatives and antioxidants. And now we're going to go over the remaining 3, which are enhancing sensory characteristics, controlling product consistency, and improving or maintaining nutritive values. So when I ask you, list the major functions of food additives, these are the 4 things that I am looking for. And notice I said when I ask you, okay? So as we go through this, each of these has a lot of discussion behind it, and there's multiple subcategories of these additives that perform each of these functions. So just keep that in mind, that these are like the big categories, and then we're going to have some subcategories that we're talking about within each one. Okay. So moving on to enhancing sensory characteristics, we have 4 potential types of additives that are subcategories of this function. One is coloring agents, flavoring agents, flavor enhancers, which is a little bit different than flavoring agents. It's not adding a flavor, it's just enhancing the flavor that's already there, and sweeteners. So for coloring agents, there are 2 forms, 2 general categories of coloring agents. The first is natural, and the next one will be synthetic. And so natural coloring agents are, of course, going to be extracted from plant, animal, or mineral sources. It's something that is naturally found in the environment, and there may be a complex process of extracting that particular coloring agent, but it is coming from a natural source. It is not being made synthetically in a lab. So some examples of these, the vitamin beta-carotene is yellow in color and can be used as a colorant. Turmeric is orange. Saffron produces a yellow-orange dye. Paprika you can use to color foods reddish orange, and squid ink is a source of black. There's also, this is a mineral source, ferrous gluconate is also a source of black coloring. Now for all of these coloring agents, they still must be listed on the product ingredients. So no matter which of these you use, you have to say in the ingredient label, list it out specifically. If you're using it for coloring, you must list what the coloring agent is, even if it's natural. So we had natural, now these are the synthetic, and so these are going to be made by some chemical process in, I say lab, but often manufactured on a large scale, so it's a big lab, okay? But essentially they are purely manufactured. They're coming from no natural source. Most often, these coloring agents are derived from petroleum, and that's important. Most often they're derived from petroleum. The advantages of using a synthetic coloring agent is they're often more stable than natural colors. They are less likely to oxidize and fade. And a lot of times the sourcing of it is simpler. You know, you aren't having to harvest the saffron, for example. It's just being manufactured. And so that can reduce the cost also. Whenever these are listed on the label, they're going to be identified by their use, their shade, and their number. And so you'll often see these labels kind of like these in the ingredient statement, right? FD&C yellow number 5. And so their use is the FD&C part. And what those letters mean is F means it's approved for use in food. D means it's approved for use in drugs, and C means it's approved for use in cosmetics. And so all coloring agents have this identifier with them. So if, for example, they're not approved for use in food, but they are approved in drugs and cosmetics, then the lettering at the beginning would be D and C. If it's only approved for use in cosmetics, but not food or drugs, the lettering at the beginning would just be a C. Okay. Most often, the ones that we see in food are all of the above, F, D, and C. So food, drugs, and cosmetics. Okay. And then next you have the color, the shade. So blue, green, yellow, red. And then finally the number, which is assigned to it based off, when they first produced it. They just gave it a number to go with it. So now 1, 3, 5, 40, for example. All coloring agents are required to be listed on the product label. So whether natural or synthetic, all coloring agents are required to be listed on the product label. So we had coloring agents. Now we're going to go into flavoring agents. And just like the coloring, we are going to divide this into natural or synthetic. The natural flavoring agents are generally not going to be limited in use. There's no guideline standard regulation on them. They may not be listed by name on the product label. So I'm sure you've seen this in an ingredient statement before. You have this long list of ingredients, and then in the middle of there somewhere, you just have natural flavors, and you're just like, what in the world is that? Well, that's this, okay? And they can come from many natural sources, dried leaves, barks, fruits, buds, flowers, fruit, seeds. They may be extracted. They may not just be the leaves ground up or the bark ground up. It may be an extract and of one particular flavoring part of that substance, but it is natural in source. Then we have synthetic flavoring agents, and just like the colorants, these are going to be cheaper and easier to get than natural flavors. So I think maybe the book talked about strawberries, for example, strawberry flavor. Well, there's only so much strawberries that are grown that can be set aside for just making flavorings out of the natural strawberries. And so they develop a synthetic strawberry flavor that can be produced in as much quantity as they want or need. And so it's more abundant than natural. There are over 2,000 different synthetic flavoring agents that exist. I'm going to skip this here and talk about this next part. They're usually developed by studying the compounds in natural flavors, right? So they take a strawberry and they isolate all the chemical compounds that are a part of the strawberry. And then they figure out, okay, which ones of these compounds give the actual strawberry flavor. And then they try to produce a substance that mimics that compound, and our taste buds, and well, taste buds, but really more our olfactory senses, when that substance hits those nerve endings, it detects it as that flavor. Okay, so they're trying to mimic the natural flavor compounds. Now, the problem with this is that natural foods, fruits, vegetables, whatever, their flavors are a combination of compounds. There's not usually just one compound that is producing that flavor. And so almost always these synthetic flavors fall short. Almost always. Not always, but quite often they fall short, and they don't taste, it doesn't taste exactly like a strawberry. And that's because a strawberry has multiple compounds that all work together to give that strawberry that flavor. So when these are manufactured, they are often, and here's a little vocabulary word here, esters. And an ester is an organic acid with an alcohol attached. Okay. And so that's what these flavor compounds are. And the reason for that is most often our olfactory senses that detect aroma. Because remember, taste on our tongue is just sweet, sour, salt, bitter. I'm missing one. I don't know. But taste is just those very simple tastes, right? And aroma, the true flavor of things, is actually because of how we smell as we eat. Okay. And so our olfactory, our smelling senses, detect esters better than other compounds from a odor standpoint. So when these are put on the ingredient label, there are 3 ways that a product may have to be labeled based on how much synthetic agent is used, instead how much synthetic flavor is used. So I'll kind of just use the book example because it is pretty good. So X product. So we in the book it said strawberry yogurt. Okay. Well, that means the product is made with strawberries, right? This is kind of a natural flavor, and then product. Well, the product is made with the actual source of that natural flavor. Okay. X flavored product is going to have a combination. So if it was strawberry flavored yogurt, yes, it's going to have some actual strawberries or strawberry flavoring in it from strawberries, but it's going to have some synthetic flavor also. So X flavored means it's a mixture. Now then, if it is only made with the synthetic version of that flavoring and there's no actual natural strawberry flavor in that yogurt, then it's going to have to be labeled as imitation, whatever your flavor is, strawberry in our case, product. So imitation strawberry yogurt. There's no natural strawberries in it, but it does have a synthetic strawberry flavor added. So then our third category under our sensory group for additives is flavor enhancers. And what that means is it makes the flavors that are already in that product stand out better. Now, there's 2 flavor enhancers that the book talks about. The first is just adding a little bit of salt. Not even enough to make the product taste salty, but salt can bring out other flavors. And so salt is a flavor enhancer. Now, we don't consider it necessarily an additive because it is used so commonly. It's really just listed under ingredients. But in this case, it's functioning as an additive. We're adding just enough of salt in our cake, for example, right? Salt is always a component of cake. And one of the reasons is it does help the other flavors come out in the cake. We don't want a salty cake though, right? And so it's just a small amount. Then the second flavor enhancer that the book talks about is MSG, which is monosodium glutamate. And so it's glutamate with mono 1 sodium attached to it, right? Now, the book does mention that some people do report that they have reactions to this additives, including getting headaches and facial flushing and burning sensations, and it's kind of a problem for some people. This was first kind of documented in 1968 by a researcher, and he called it Chinese restaurant syndrome because he noticed that he always got this reaction after he ate Chinese food in America. And he didn't even attribute it to MSG at the time. Other people did later on. He just knew that it was something that he always experienced after eating Chinese food. Now, MSG is used quite a bit in Chinese food, and so then later on, that reputation came and it was attributed to that. Now, I want to give this a big caveat here. Okay, so MSG is on the GRAS list for FDA. Okay, it's generally recognized as safe. FDA has found no major harmful effects from it. And so why is that? Well, so what is MSG? Okay, so glutamic acid. We've talked about glutamic acid before. It's just an amino acid, right? That's in a lot of our foods naturally. It's part of proteins. And glutamic acid, if you take off this hydrogen, and which hydrogens easily come on and off. And in fact, glutamate is a version of glutamic acid. It's still considered an amino acid. Okay, so this is the same thing with the hydrogen. It actually just moved places here. So this is a salt of glutamate and sodium. Now, what happens when salts go into solution? The ions separate, right? So the sodium, as soon as it hits the liquid in your stomach, even your saliva, the sodium separates from the glutamate. And so in your stomach, in your body, this is converted immediately to glutamate, just the same as glutamic acid is converted to glutamate in your body. Okay, monopotassium glutamate would be similar to MSG, it's just with potassium. Okay, so why would this cause more problems than this? Okay, and that is a big question. One that there is no scientific answer to, because when actual studies have been performed of people consuming normal amounts of MSG, there's been absolutely no link between MSG consumption and headaches or nausea or any other symptoms. Okay. So, and so that there's actually a review that was done in the past 10 years of 17 different studies that they looked at, and they could not find a link between MSG and any of these symptoms that are often anecdotally reported. And so I want to point out that so average consumption, this is a little thing I found online. Average consumption of MSG by the average consumer in the USA is a little over 0.5 gram a day. But daily, we ingest 20 to 40 times more naturally occurring glutamate in our foods. Glutamate is in lots of foods. It's high in tomatoes, in Parmesan, in mushrooms, in soy sauce, in potatoes. And once again, as soon as that monosodium glutamate hits inside our bodies, it's converted to glutamate, which is the exact same chemically as this naturally occurring glutamate. So most likely, the criticisms of MSG and Chinese restaurant syndrome is a purely anecdotal thing. Maybe there's something else in the Chinese food that is causing it, but it's probably not MSG. Either that, or it's a placebo effect, and it's more in people's heads that they're going to have this symptom, and then they do. So, scientifically, no evidence for this. Okay, and then our final additive subcategory under our sensory additives is sweeteners, and I'm not going to spend much time on this at all because we just finished going through a big chapter on sweeteners. Okay, so once again, we have the nutritive sweeteners, we have non-nutritive sweeteners, and you remember which ones are in each of those, right? In the nutritive, we have our different sugars, as well as our sugar alcohols, which are lower in calories, but still contain calories. And then our nutritive includes things like aspartame, saccharin, sucralose, etc. So now our third major function of food additives. Okay, I have this bolded to show you now we're we're in the big category, big heading of food additive functions. And our subcategories here is a long list, okay? We have anti-caking agents, emulsifiers, humectants, leavening agents, maturing and bleaching agents, pH control agents, stabilizers, and thickeners. I've made this slide here for you just so you have this whole list in one place to help you out with studying. Okay, so first our anti-caking agent. So an anti-caking agent, its purpose is to absorb moisture so that powders or crystalline ingredients in general, there's some exceptions, do not cake or form lumps. So they don't stick together, so that they are pourable, right? That you can easily pour it or scoop it or whatever without lumps being there. So major additive ingredients that are anti-caking agents: calcium silicate, silicon dioxide, dicalcium phosphate. So notice these are both silicone, silica. We'll say on these, so these have been added for forever, and because silicon is long thought to be inert in our bodies, but I will point out there is some recent research that silica is not as inert as once thought. Essentially, silica is a big component of sand, okay? And so that's why they thought not that big a deal. But there is some recent research that does show that it may cause some oxidative stress in our body, which a lot of things cause oxidative stress in our bodies. But essentially, they thought it didn't react with anything in our body. Well, it actually might, and be somewhat negative. Now, like I said, lots of things cause oxidative stress in our body. Salt causes oxidative stress in our body. So take that with its own little grain of silica. Okay. So food product examples that we can find anti-caking agents in would be salt, because salt does tend to clump up, right? Baking powder, confectioner sugar, so powdered sugar, flour, and I added this one. This was not in the book, but it's one I'm well aware of, is shredded cheese. So with shredded cheese, you'll often see potato starch or microcrystalline cellulose. So these are different than these, and it's serving a little bit of different function as an anti-caking agent than it does with these powders. But if you don't have the starch or microcrystalline cellulose is sometimes used, then the cheese will clump together and stick together. And so what that is doing is actually like adding a moisture barrier around each shred of cheese to prevent them from sticking together. In flour, I'll also say, so because flour has anti-caking agents in it, or anti-caking agents can help flour, you'll often see these anti-caking agents also, of course, in things that flour is in. So like baking mixes, you'll find these anti-caking agents in. Okay, so next, under our group of things that control product consistency is emulsifiers. And we've talked quite a bit about emulsifiers before in several chapters, but once again, emulsifiers are additives that help mix two immiscible liquids that don't normally mix, right, into an emulsion. Their major function is to keep those ingredients mixed together and not separating. They also help disperse those flavoring agents that we've talked about, those esters. Those esters might not want to mix into a liquid, into liquid substances and stay mixed in. They might tend to separate. And so these emulsifiers can help disperse those flavoring agents so the flavors are dispersed throughout and not separating to the top or the bottom of the container. So most of our emulsifiers are natural. So we have lecithin, which we've talked about before. There's several sources of lecithin. We've focused a little bit on the egg yolks, but it's also found in milk. It's found in soybeans. It's found in sunflower seeds. A lot of times, like on your mayonnaise, you'll see sunflower lecithin, or safflower, maybe safflower is one too. But you'll see lecithin, and then you'll also see what the source is. Mono and diglycerides, these are also natural. They are usually extracted from vegetables or animal fat. Now, these serve multiple functions here. They can be emulsifiers, and for specifically these mono and diglycerides, they can also work as lubricants and binders in the food. So multiple functionality in some of these additives. Okay, the third one here is humectants. And these are additives that are used to help products maintain moisture. So in the other one, we're trying to keep the moisture out of it. And so that silica grabs any moisture and is able to hold on to that moisture and keep it from interacting with the powder. With the humectants, we're actually trying to just keep moisture in the product so that it stays moist. Okay. The other advantages to humectants is they can control crystal growth and just in general regulate the water activity in that product. They do affect the texture of the product, and kind of like what we talked about previously with the emulsifiers, these can carry flavor compounds also. So some additive examples: propylene glycol, this is synthetic. Glycerol, sorbitol, and mannitol can be derived naturally. The book doesn't list these two, but sugar, and honey too, because honey is sugar. Sugar is a humectant. So just the fact that sugar is in a product can help keep it moist. So some food product examples: marshmallows can sometimes have humectants. Flaked coconut, soft candy, chewing gum, and other confections often have humectants. A couple examples that I found doing some internet searches: Twinkies have glycerin in them. This extra gum has 3 different humectants in it. Now, this is sugar-free gum, so it has sorbitol and mannitol in it, which they're going to serve 2 purposes, right? They are sweeteners and they're going to act as humectants. And then it also has glycerol in it. Okay, so continuing on, our next one is leavening agents, and we've kind of talked about these before too, but I'll add some extra information here because we haven't really dug into yeast very much. So, of course, leavening agents, as we've talked about before, are additives that are used to increase the volume, and of course they are going to alter the texture of baked goods by adding that airiness to them. Now, there's 2 categories of leavening agents, right? There's yeast, and then there's our chemical leavening agents. And we haven't talked a whole lot about yeast, and so I'm going to give some more information on that. So there's 3 main types of yeast that you can get in the store. And so hopefully this information will help you determine what type for you to get if you were cooking. So there's active dry yeast, okay? And this type of yeast is dried with heat. And what happens is many yeast cells will die in the process because it's not the most gentle way to dry that yeast. And so for each little granule of yeast, there's more than one molecule, or not molecule, more than one yeast organism in there, okay? And what's happened with the active dry yeast is so there's this granule. Well, all of the yeast cells that are on the outside of that granule have died in that process. So they're just dried, dead yeast cells. But then on the inside of that granule, those dead cells are surrounding living cells. Okay? And so what that means for this type of yeast is that you first need to soak that yeast in warm water to activate it. And what you're doing there is sloughing off the dead cells and allowing the water to reach that center of the granule where the live yeast is. Okay. Instant yeast here is dried with a little bit gentler process. And so in those, all of the yeast cells in that packet are living. To an extent, there is, like, if it's really old, then they might have died. But, you know, as of the time that it's produced, all the particles are living. And so the instant yeast, as compared to active dry yeast, is able to be mixed directly with the recipe ingredients because it can start working immediately and doesn't have to wait for those dead cells on the outside to be sloughed off. Then the third type of yeast that you can buy is fresh yeast. And this is sold as a compressed cake of yeast. I believe it usually has to be refrigerated. And it's 70% water by weight. It hasn't been dried at all. It's just the yeast have been just compressed into a block altogether. And it looks kind of like this. So like this is just yeast powder. It could be either of those. And this is what that fresh yeast looks like when you take it out of the package. It is 100% living cells, but because it's fresh, it's highly perishable. And so, like I said, it's typically going to be refrigerated, and even then, it's not going to last as long as these dried yeasts. Now, active dry yeast is also known to be fairly perishable. It is stable at room temperature, but it goes bad faster than the instant yeast. So overall, instant yeast, you know, after all this discussion I've had, instant yeast is really the best option most of the time. Most, if not all, of the particles are going to be living when you use it. You can mix it directly with the recipe, and it's shelf stable in your cabinet for a longer time than the fresh yeast. Now, as an extra note, when you look at the ingredient statements on these, ammonium sulfate and ascorbic acid may be included with that yeast, and generally those are not really to protect the yeast in the package. They're to help the yeast grow when you add it to your product that you're making. So the ammonium sulfate, the reason that is used is ammonia, right, has nitrogen in it, and the yeast use the nitrogen to grow as a nutrient source. And then ascorbic acid creates a slightly acidic environment that helps the yeast grow also. They like it to be a little bit acidic when they're growing, and so having that ascorbic acid can help with that. So the yeast is, of course, our natural leavening agent, and then we have our chemical leavening agents. We've talked about these before early in the year. I'm not going to go over them in depth again. So baking soda, baking powder, those are our main chemical leavening agents that we use. Okay. Then we have maturing and bleaching agents, and these are specifically going to be referring to flour, the additives added to flour. So the problem is that flour that is freshly ground creates a sticky dough that is hard to work with. And so to have a better flour, you actually age it. You just let it sit for a while before you use it. And so over time, it naturally oxidizes. And in that oxidation process, it becomes whiter in color. And when you're using it, the dough is less sticky and is easier to work with. Well, in the food industry, letting anything sit for a while before you're able to use it or sell it, that is a use of space and time, which is a cost, a monetary cost, because now you can't fill that space and keep product moving and things. That's why dry cured ham, like my prosciutto, is way more expensive than the ham that you get just in a lunch meat package in the grocery store, because there's a cost associated with that longer storage that aging of the product. And so the solution that the food industry came up with is maturing and bleaching agents. And these are chemicals that speed up that aging process that manufacturers would have before they let consumers have the flour, but doing it chemically and making it go faster. So they don't have that loss in time and space. So what these agents do, they generally improve that flour, and then the agents break down. So after they do their work, they are no longer detectable as whatever they were added as to begin with, and they leave very little residue. So you're not going to find these maturing and bleaching agents necessarily if you do a test on the flour, because they've broken down, and then often they have just evaporated into the air, and you'll see why in a second. Sometimes these agents can be added as dough conditioners during dough mixing, so not just added to the flour, but during the mixing of the dough, you add these agents as conditioners, and that helps prevent some of the stickiness that can happen with fresh flour. So some agents perform the maturing function only, some perform the bleaching function only, making the flour whiter, and some do both. Okay, so agents that mature the flour, that just do that oxidation process and get that dough less sticky, include chlorine dioxide, ascorbic acid, and potassium bromate. All right. Bleaching agents include chlorine dioxide, benzoyl peroxide, and chlorine gas. Now, I'm not as familiar with these here, but chlorine dioxide, okay, so let's think about what happens when this breaks down. It's made out of chlorine and oxygen, okay? So if it's made out of chlorine and oxygen, well, chlorine is a gas. If it breaks down, right, it's going to break down into two things, chlorine and oxygen. Chlorine is a gas, oxygen is a gas. So if these perform their function and then break down, both of those completely evaporate into the air and are no longer a part of the flour. And so that is kind of what this is referring to. Here, where it's little residue. Okay, and now pH control agents. So a pH control agent is any additive that alters or stabilizes the pH of a mixture. So it can change it, or the focus can be to keep it the same. So there are three general categories of pH control agents. The first would be acids. We're very familiar with acids. Why we would particularly add acids? We can use it for preservation. We've talked about that function of acids before. Flavor, right? Acids give a sour flavor, but it can also enhance other flavors potentially. Acids can change the texture. We can use it for hydrolysis, and we can use them for prevention of crystal formation. And we've talked about a lot of different acids that are used in foods before: acetic acid, citric acid, phosphoric acid is used in sodas, for example, etc. Okay, then of course bases, right? So these are the two obvious ones, right? We're going to change the pH, alter the pH, it's acids or bases, right? So why we would add bases, we would add them to enhance color and flavor. So a lot of times we add that base and the color pops more. We could add bases to thicken texture, and an example that the book talked about is fruit peeling. So sodium hydroxide, which can be a very strong acid, can be used to peel fruit, and then you have peeled fruit, and then you can move on to your next part of the process. Sodium hydroxide, sodium bicarbonate, calcium hydroxide are examples of bases that are used. Now, our third way that we control the pH is by using buffers, and the particular function of these is to stabilize the pH. Now, some of these buffers are also acids or bases. All right. They give a pH, but they also have a function where they like to keep that pH the same. I'm not going to get into the chemical reason why, but buffering ingredients essentially resist any kind of significant pH change from what they are at, even when small amounts of acids or bases are added. That's what a buffer is, okay? They keep the pH stable. Now, they can change the pH when they're initially added, but they, in general, like once they've been added, their function in that food is to keep the pH stable. So, examples of buffers, sodium salts. So sodium bicarbonate is a sodium salt. It is a base and it is a buffer. Okay. So salts can be used as buffers, not like sodium chloride. That's not going to be one, but other salts can. Just remember that sodium chloride, potassium chloride, those are not the only salts. The definition of a salt is not just sodium chloride. Citrates, phosphates. Phosphates are also a base that is used as a buffer, and phosphates are a very good buffer at keeping the pH usually at just a slightly basic point. Usually it's somewhere around like 7.5 to 9 range that phosphates keep the pH at. Or they can be used to raise the pH and keep it at a certain level. Proteins, some proteins can be used as buffers. There are some acids that can be used as buffers. So they're an acid, but they also have a functionality where they resist pH change from their acidity, and so they're going to keep that food product at that acidic level. Phosphate salts, so again, more salts. And phosphates, so they're going to be basic there. Okay, and then we have stabilizers and thickeners. These are additives that are used to help control the consistency of the food. Now, they are not exactly the same thing. So stabilizers, their main goals are to keep the product in the same form as when it was first made. That would be the general definition, okay? To keep the product in the same form as when it was first made. So, for example, to keep ingredients from settling. When I first made this chocolate milk, it was this nice dark brown color. I don't want it to look like this, where all of the cocoa settles to the bottom. To keep flavor, this should be from evaporating. So some flavors do tend to volatilize and go away, right? We want to keep those flavors in the food product. To keep ice crystals from forming. So, in ice cream, for example. You may have also noticed if you ever have eaten from a tub of ice cream that is old, not only do ice crystals form, but like sugar crystals can form, and that ice cream becomes more grainy over time, and these stabilizers can keep that from happening as quickly. Then, of course, thickeners, their goal is to thicken, right? And so that's to increase viscosity. It may thicken it so much that it forms gels, okay? So thickening is a broad range. Most of the stabilizers and thickeners are natural carbohydrates. And the reason that these are kind of put together in the same group is that a lot of these carbohydrates, they perform both functions. They act as stabilizers and thickeners. So examples, these are things that we've already talked about before, right? Pectin, alginates, carrageenan, gums. These are all carbohydrates that we've talked about before that do provide some stability and thickening to food products. The nice thing about this chapter is, even though there's lots of lists and things, a lot of this is review of some things that we've already talked about. Okay, so if the couple examples that are not natural carbohydrates, remember most of these stabilizers and thickeners are going to be carbohydrates, but a couple that are not. Gelatin, we remember, is a protein, and propylene glycol, that is a synthetic stabilizer and thickener that is added to foods. Okay, So our next major function of food additives is to improve or maintain nutritive value. And we've essentially talked about this before in 2 chapters ago when we did vitamins and minerals. So fortification and enrichment, right? So adding vitamins and minerals to products, whether it's because whether it's because we lost some of those due to processing and we're restoring them, or because we're just trying to add them to help the population get enough of a certain vitamin or mineral. And just remember with these that no matter how much you fortify and enrich things, you can't really, fortification and enrichment cannot take the place of a healthy diet. You should be eating a well-rounded diet with not like solely processed foods, right? Okay, so that was the end of the main functions of additives. And so now we have just a couple more slides with those last 2 sections in the chapter. So the first is about secondary intentional additives. The key focus here is enzymes being used as a processing aid. And so the way a processing aid works, it is in contact with the product, but then it's usually taken out in some way, whether it evaporates itself out or it's extracted out or whatever. But it performs some function in the product and then it's generally removed. So enzymes can be used as processing aids. If they have to be FDA approved, okay? And also whatever you add to the product that the enzymes are going to utilize to then produce their byproduct, that also must be FDA approved. And so why we do this, the enzymes will be added to the product in some way. They're going to produce some desired additive, some byproduct that the enzyme makes, or perform some function in the food. And then usually that enzyme is going to be either destroyed with heat or more likely filtered out. And in fact, sometimes it's not even a filtered out process. It's just like the enzyme is on like this stable bed, and it does not come off of it, and the product is run over the enzyme, and then the product moves on. That's one way that enzymes can be used as these secondary additives. So why we do this, the enzymes, so let me back up. So some examples of the processing aid functions, right? The enzymes, they can improve flavor, they can improve texture, they can be used to improve the digestibility and the nutritional value of foods. They can stabilize the flavor and color of foods. We've talked before about how some enzymes can be used to like clarify fruit juices and things. And so this can replace the use of chemical additives, making for a cleaner label. So that's good. And the enzymes are also reusable. So as long as you don't destroy them with heat, right, you can reuse them, and then you're kind of decreasing a cost because you're not constantly buying more ingredient to add to the product. You're just reusing these enzymes. Now, the last section, or last paragraph of this section, don't even read it. It's awful. I read it and I literally went out loud, what? So the last section talking about how cattle are injected with papain before slaughter, and that makes the meat more tender. And this does not happen. It's wrong. So in the 1960s, there were several research studies that looked at this, and patents for this were approved. And so how that would work is that after the cattle had been stunned, so you remember we kind of watched some of this when we went to the meat lab earlier this school year. The cattle are stunned. There's a bolt that goes through the top of their head, so their brain is essentially dead. They're never going to wake up. Okay, but so they can't feel anything. So after the animal's stunned, they inject the papain into their bloodstream, right? So they'll like inject it into their artery. and their heart is still pumping. So they are unconscious, insensible, but still alive. Their heart is still beating, and the enzyme papain is then going to be transported throughout the body and into the muscle tissues. And it did work. However, this never took off as a common practice, and it is most definitely not done today. It is technically legal. Um, it and has been approved by USDA, but it's not done in actuality. And if it were, it would have to be on the label. You would have to have on your steak that you get at the grocery store, it would say the words tenderized with papain. And you don't see that, right? So while it's possible, it is not, absolutely not a common practice. And don't assume that all the beef that you get in the grocery store has been injected with this enzyme, because it hasn't, not the case. So yeah, that is the one. There's been a lot of errors and things in this book that I've had to clarify, but this one actually made me mad. Okay, so the last slide here, it's about balancing the benefits and risks of additives. So let's first go over the benefits. But additives decrease the cost of food because we are able to manipulate the food more easily to produce a desired outcome. We are able to make food last longer, and so that decreases the cost of food because it's not having to be constantly produced in a way that it's always fresh, and like right off the line, and there's less waste that happens, right? They increase the variety of food because of the use of additives. There's a creativity that can happen that allows for a lot more different types of food to be produced. They are essential for what we see as convenience foods today. Without additives, we would not be able to have foods that you can just unwrap and eat, right? They are good for jobs and the economy, because the food industry is a big thing. And there's jobs that are producing the additives for food scientists who are coming up with creative ways to use them, etc. Of course, there are some concerns. And one of them is, are some additives more harmful than previously thought? Because science is ever evolving, right? And so some things that we think are safe, we may find 5, 10, 100 years down the road that they were not as safe as originally thought. The book talks about a system called ARMS that can be used to report adverse events. So like, hey, I consume this additive and I think that it caused me to whatever. This, it's not a mistake in the book. It was probably accurate when it was written, but now ARMS does not exist, and instead there is the CARES, which CFSAN stands for the Center for Food Safety and Applied Nutrition. You don't have to know that, but it's part of the FDA. So this still is part of the FDA. It just has a different name, it's maybe slightly different system. And so it's the same function, right? Adverse reaction, adverse event reporting system. And so this is where if you did have a reaction to an additive, you could report it to the FDA, and it's something that they monitor and figure out, okay, do we need to take another look at this ingredient? So ways that you can reduce risk is, just limiting the consumption of your processed foods, right? The more whole foods you eat, the less additives you are consuming, and the less processed foods, generally, the better. There's less questions, and although like I am not anti-processed foods, overall, if your diet is only that, it is going to be less healthy than if you are eating a diet of whole foods, of fruits and vegetables and meats. Also, you can wash your fruits and vegetables. That isn't necessarily an additive thing, but pesticides are used on fruits and vegetables, and so you can limit your exposure to that by washing fruits and vegetables. Reading labels, right? So taking what you have learned in this class and read the labels and like, okay, I know what this ingredient is used for. And if you don't, be curious and look it up. Overall, it's just staying informed, right? Like that, be curious, look it up. Um, be aware of what you are putting into your body. And so ultimately, the responsibility for consuming safe foods is at all parts of the food production, food consumption chain, right? The FDA approves the use of these additives after the manufacturer gives them evidence that it's safe. The manufacturer, after FDA approval, they're the ones responsible for adding that additive at safe levels. And then you, the consumer, are responsible for being informed and understanding what the additives are and knowing what you do and do not want to put in your body. So everyone is responsible for safe food. And that goes, well, we're going to be getting into food safety later in the book, but that goes for that too, right? When we go into food safety chapters, the government agencies, yes, they do inspection and have regulations that help keep food safe, but the manufacturer ultimately has to follow them. And then you, as the consumer, have to make sure that you are treating food in a safe manner at home so that you are not making the problem worse for yourself. So that is where we will end today. And that's it. Y'all have a great week.